Welcome to MRL. Today's learning session is on natural numbers. Now, what are natural numbers? Natural numbers are counting numbers. The numbers which are used for counting. The 1, 2, 3, 4, 5, 6, 7 and so on are counting numbers and are known as natural numbers. A set of natural numbers is represented by the symbol n, and n is equal to 1, 2, 3, 4, 5, 6 is a set of natural numbers. The smallest natural number is 1. The greatest natural number is infinite, and the consecutive natural numbers differ by 1. 1 is the first natural number. 2 is 1 more than 1 is the second natural number. 3 is 1 more than 2 is the third natural number, and so on. The successor of 1 is 2. Successor of 1 is 2 because 2 is 1 more than 1, and successor of 2 is 3 because 3 is 1 more than 2. Successor of 3 is 4, and so on. So also the predecessor of 3 is 2 because 2 is 1 less than 3. The predecessor of 2 is 1 because 1 is 1 less than 2. But there is no predecessor for 1 in a set of natural numbers. So every natural number has a successor, but every natural number does not have a predecessor because 1 does not have a predecessor. So please remember that. And all these numbers 1, 2, 3, 4, 5, 6 are called as consecutive numbers because every number is 1 more than the previous number. Now the natural numbers can be represented on a number line. First of all, what is a number line? A number line means a line which represents numbers. But a line which represents natural numbers is a natural numbers number line. How do we draw a natural numbers number line? First draw a line, and the point A on the line represents 1, the point B represents 2, C represents 3, D represents 4, and so on. So this is a natural numbers number line. But ensure or make it a point that all these numbers which are represented on the number line are represented at equal distances from each other. Now, operations on natural numbers. Now, what are these operations? What are the fundamental operations on a set of natural numbers? The fundamental operations in mathematics are addition, subtraction, multiplication, and division. Now, let us understand about addition. Now, when we take two natural numbers 3 and 4, when we add we get 7, again a natural number. Therefore, addition is possible for a set of natural numbers. Subtraction. When you take a natural number 5 and subtract it from 7, we get 2. 2 is again a natural number. That means subtraction is possible for a set of natural numbers, but not always possible because we cannot subtract a bigger number from a smaller number. The number will be a negative number, which is not possible for a set of natural numbers. Multiplication. When you take a number 6 and multiply by 3, we get 18. 18 is also a natural number. Therefore, multiplication is possible for a set of natural numbers. Division. 6 divided by 3. 6 is a natural number. Divided by 3, that is 2. 2 is again a natural number. That is how we carry out the operations on natural numbers. That means addition, subtraction, multiplication, and division are possible for a set of natural numbers, except for subtraction and division, where it is not always possible. And before we proceed further, let us understand the different properties which are possible for a set of natural numbers. The properties which are closed for a set of natural numbers are 8 of them, and we will be learning them one by one. So let us start with the closure property of addition. The closure property of addition, if you take a set of natural numbers, that is n is equal to 1, 2, 3, 4, 5 and so on, and you take any two natural numbers 2 and 4, when we add we get 6. 2 belongs to n, 4 belongs to n, 6 belongs to n. Sum of two natural numbers is again a natural number, and therefore closure property of addition is closed for a set of natural numbers. That is, for all AB belonging to n, A plus B is equal to C. C also belongs to n. Therefore, closure property of addition is closed for a set of natural numbers. That is, closure property of addition is closed for a set of natural numbers. The next property is the closure property of multiplication. For a set of natural numbers, if 2 and 4 are two natural numbers, when we multiply, we get 8. 2 into 4 is 8. This is wrong here. It is not 6, it is 8. So 2 belongs to n, 4 belongs to n, 8 belongs to n. Therefore, product of two natural numbers is again a natural number. Therefore, closure property of multiplication is closed for a set of natural numbers. If you take any two natural numbers a and b and multiply, we get c. If c is also a natural number, then the closure property of multiplication is closed for a set of natural numbers. The next property which we have to learn is the commutative property of addition. Now, what is this commutative property? If you take any two numbers, you can add them in any order. You can add a to b or b to a. That is, a plus b is equal to b plus a is what is the commutative property of addition, and that is applicable for a set of natural numbers. For example, if you take 2 and 3 are two natural numbers, when we add 2 to 3 we get 5. When we add 3 to 2 also we get 5. Therefore, addition of 2 to 3 or 3 to 2 is again the same, and 2 belongs to n, 3 belongs to n, 5 belongs to n. Therefore, commutative property of addition is closed for a set of natural numbers. Remember that. Now, coming to the commutative property of multiplication. Now, what is this commutative property of multiplication? Multiplication of two numbers in any order is the same. Whether you multiply a by b or b by a, the answer is the same, and therefore commutative property is closed. For a set of natural numbers, if you take 2 and 3, 2 into 3 is 6, 3 into 2 is 6, 2 belongs to n, 3 belongs to n, 6 also belongs to n. The answer is 6 and 6 for both, that is LHS is equal to RHS. The commutative property of multiplication is closed for a set of natural numbers. Now, coming to the next important property, that is associative property of addition. N is a set of natural numbers. If you take three numbers 2, 3 and 5, add 3 to 2 and then add 5, you will get 5 plus 5, that is 10. Add 3 and 5, we get 8. Add to 2, we get 10. LHS is equal to RHS. The numbers of n can be grouped and added in any order. For all ABC belonging to n, a plus b plus c is equal to a plus b plus c. Therefore, associative property of addition is closed for a set of natural numbers. Now, let us understand the next property, that is associative property of multiplication. 2 into 3, if I multiply, I get 6. When I multiply again by 5, we get 30. If I multiply 3 into 5, I get 15. When I multiply by 2, I get 30. LHS is equal to RHS. That means for all ABC belonging to n, a into b into c is equal to a into b into c. Therefore, associative property of multiplication is also closed for a set of natural numbers. Now, the next important property is the distributive property of multiplication over addition. Now, what does this mean to us? If you take three numbers 2, 3, 5, now when I multiply 2 with the addition of 3 and 5, 3 plus 5 is 8, 2 into 8 is 16, or 2 into 3 plus 2 into 5 will give 6 plus 10, that is also 16, and that means LHS is equal to RHS, that is the distributive property of multiplication is closed for a set of natural numbers. So, if a, b, c belong to n, a in the bracket b plus c is equal to a into b plus a into c, that means LHS is equal to RHS, which is true for a set of natural numbers, which is closed for a set of natural numbers. Now, multiplicative identity. If you have a set n is equal to 1, 2, 3, 4, 5, if I multiply 5 and 1, we get 5 again. 5 is a natural number, 1 is a natural number. When I multiply 5 into 1 again, I get by 5. So, when we get the 5 again as 5, when multiplied by 1, then 1 is called as the multiplicative identity, which is possible for a set of natural numbers. Now, having understood all these properties, let us list out the properties which are closed for a set of natural numbers. Closure property of addition, that is a plus b is equal to c. A is a natural number, b is a natural number. When you add, we get again a natural number. Therefore, closure property of addition is closed for a set of natural numbers. So also closure property of multiplication, commutative property of addition, commutative property of multiplication, associative property of addition, associative property of multiplication, distributive property, and multiplicative identity. So these are the 8 properties which are closed for a set of natural numbers, and these are the properties which are the general forms of the properties which are closed for a set of natural numbers. Now, how to understand and remember what we have learnt in this session? The very simple method is, first listen to what I have spoken and also read. Second, again only read Third, only hear and then repeat your reading and hearing sessions. Practice and write down in a book if possible, so that it will be a reference for you for your future understanding and reading. Thank you.